Here's problem 35.5. An experiment to measure the speed of light uses an apparatus similar to Fizeau's. The distance between the light source and the mirror is 10 meters and the wheel has 800 notches. If the wheel rotates at 9,000 revolutions per second when the light from the source is extinguished, what is the experimental value for C in meters per second? Okay, let's take a look at this experiment. We've got a wheel with a bunch of notches, 800 of them to be exact, all the way around. And light is going through the space between the notches, reflecting off a mirror and then coming back. And when it comes back, it hits one of the notches, and that's why we know that the light is distinguished. So we keep on speeding it up until the point at which we see that the image is extinguished. This distance here is 10 meters. So basically the light's going to travel there and back again in the time it takes for it to rotate through to the notch. But we have 800 notches. The rotation actually is going to be one half of the angle associated with a notch. In other words, the angle here associated with the notch and the space. So we're going to have a angular change that's actually going to be equal to 1/1600th of a revolution for it to extinguish the light on its return. And we know that this angular change is going to equal the angular velocity times time. So time will equal the angular change over the angular velocity. The time then is going to be equal to 1/1600th of a revolution over the angular velocity, which is 9,000 revolutions per second. And then what does that give us? .94 times 10 to the minus 8 seconds. So that's how much time we're talking about. We know that the distance should equal velocity times time. So the velocity of the light will equal the distance divided by time. And that is going to be 20 meters there and back again over 6.94 times 10 to the minus 8. And what does that give us? 2.88 times 10 to the 8. Meters per second. So the velocity measured using this method is 2.88 times 10 to the 8 meters per second.